Hello everyone, welcome back to Brand Insider, and in today's video I'm going to tell you everything you need to know about nanotechnology. But before we start, be sure to subscribe to the channel and don't forget to hit the bell icon so you don't miss any updates. Nanotechnology, also known as nanotech, is the exploitation of problems at the atomic, molecular and supramolecular levels for commercial purposes. The earliest prevalent explanation of nanotechnology described the technical goal of precisely manipulating atoms and also particles to make macro-scale items, likewise right now described as molecular nanotechnology. Nanotechnology is the adjustment of the issue along with at least one measurement of 1 to 100 nanometers in size. Nanotechnology, as specified by dimension, is usually vast and encompasses areas of scientific research as diverse as surface science, natural chemistry, molecular biology, semiconductor physics, power storage, design, microfabrication, and also molecular design. The ideas underlying nanotechnology were first introduced in 1959 by the well-known physicist Richard Feynman in his lecture "There is Loads of Space at the Lower," in which he explained the possibility of formation by selective adjustment of atoms. The term nanotechnology was first used by Norio Taniguchi in 1974, but was not widely understood. Inspired by Feynman's ideas, K. Eric Drexler used the term nanotechnology in his 1986 book, Motors of Production: The Happening Period of Nanotechnology, which raised the idea of nanoscale assemblers, capable of producing a duplicate of itself and also of various other things with approximate complexity and atomic management. Also in 1986, Drexler co-founded the Foresight Principle, with which he is no longer associated, to improve community understanding of the ideas and implications of nanotechnology. The introduction of nanotechnology as a field in the 1980s developed with the convergence of Drexler's academic and also community work, designing and also promoting a conceptual platform for nanotechnology, and also highly visible speculative advances that attracted extra wide-ranging focus on the guides of atomic management of problems. In the 1980s, two primary innovations triggered the development of nanotechnology in the present day. First, the invention of the microscopic tunneling lens in 1981, which provided remarkable visual images of individual atoms and bonds, and was also efficiently used to set individual atoms in 1989. The microscope's programmers, Gerd Binning and Heinrich Roher of the IBM Zurich Analysis Lab, received a Nobel Prize in Physics in 1986. In the early 2000s, interest grew in medicine, politics and government, leading to both disputes and developments. Conflicts arose over the interpretation and potential impact of nanotechnologies, illustrated by the Imperial Society's records on nanotechnology. Issues were raised regarding the appropriateness of the applications presented by the promotion of molecular nanotechnology. On the other hand, the commercialization of products based on improvements in nanoscale innovations began. These products are limited to the mass use of nanomaterials and also do not involve atomic management of problems. Some examples are the silver nanosystem for using silver nanoparticles as an antibacterial agent, nanoparticle-based sunscreens, carbon dioxide fibers made with silica nanoparticles, and carbon dioxide nanotubes for stain-repellent wipes. In the mid-2000s, a brand new and strong medical interest began to grow. Orders emerged to create nanotechnology roadmaps that focused on atomically specific adaptations of problems and also covered current and projected capabilities, targets, and uses. In 2006, a group of Oriental scientists from the Korea Evolved Principle of Scientific Research and Modern Technology, or KAIST, and the nationwide Nanograte facility developed a 3 nanometer MOSFET, the world's smallest nanoelectronic device. Nanotechnology is the design of useful entities at the molecular level. It deals with both existing and advancing ideas. In its own authentic feel, nanotechnology refers to the predicted capability to build things from the very bottom up, utilizing approaches and also resources that are actually being developed today to create more powerful items. A nanometer is actually 1/1000th or even 10 to the power of 9 of a measurement. For comparison, the normal duration of a carbon-to-carbon bond, or even the distance between these atoms in a molecule, is in the range of 0.12 to 0.15 nanometers, and also a DNA double helix has a size of about 2 nanometers. In contrast, the smallest mobile lifeforms, the microorganisms of the genus Mycoplasma, are about 200 nanometers in size. Conventionally, nanotechnology is understood to be within the range from 1 to 100 nanometers, according to the interpretation of the nationwide nanotechnology campaign in the USA. The lower limit is actually a collection due to the dimension of atoms. Hydrogen has actually the smallest atoms, which are about 1/4 of a nanometer sized. Considering that nanotechnology should create its own tools from atoms and also particles, the upper limit is basically just an approximation. But it is the dimension below which phenomena that cannot be observed in larger systems emerge and also can be used in nano devices. These brand new phenomena create nanotechnology as opposed to tools that are actually just miniaturized models of a comparable macroscopic device. Such tools perform a wider range and also happen under the explanation of microtechnology. To put this reach in a different light, the dimension of a nanometer compared to a measuring device is equivalent to that of a marble compared to the size of the planet. Or to put it another way, a nanometer is the volume by which a typical man's beard expands in the time it takes him to bring a razor to his skin. Two primary methods are used in nanotechnology. In the bottom-up method, components and tools are made from molecular elements that chemically build themselves through the guidelines of molecular consciousness. In the top-down method, nano-objects are created from larger plants without management at the atomic level. So, what is the potential of nanotechnology and how does it benefit humanity? Modern wearable technology for health and fitness means that we can easily check our well-being by strapping gizmos to ourselves. Certainly, there are digital tattoo models that can easily scan our essential indicators. However, by scaling down this modern technology, we could potentially go further by implanting or even infusing very small sensor units into our body systems. This will provide so much more outlined information, along with much less difficulty to squeeze into the person, allowing doctors to adapt their procedures. The fight against environmental change shows that we need brand new methods to generate and also use energy, and nanotechnology is actually involved in that task. It has helped develop electric batteries that can easily store more electricity for cars and trucks, and it has enabled photovoltaic systems to convert more sunlight into energy. The common technique in any application is to use nanotextures or even nanomaterials that transform a standard surface into a three-dimensional surface with a much larger surface area. This means that there is more space for the reactions that allow electricity to be stored or even aged, so that the tools function more successfully. In the long run, nanotechnology could allow competitors to harvest electricity from the atmosphere. Brand new nanomaterials and also ideas are actually currently being designed that show possibilities for generating electricity from action, lighting, variations in temperature, sugar, and also various other resources, along with higher conversion productivity. When splits occur, nanotechnology could possibly take part in another task. Transforming the framework of components at the nanoscale can easily provide some fantastic housing, by providing a structure that repels sprinklers, for example. In the future, nanotechnology layers or even ingredients will definitely also have the ability to allow components to recover when damaged or even destroyed. The distribution of nanoparticles in products, for example, means that they can easily move to fill cracks that appear. This could potentially create self-healing components for everything from aircraft cockpits to microelectronics, preventing small cracks from becoming large, more problematic cracks. Sensors will definitely generate more information than we've ever had to process before, so we'll need the modern technology to process it and also place the designs that will definitely inform our business about problems. The same is true if we want to use the huge information that comes from website traffic capture devices to fix blockages and prevent incidents or even prevent crimes by using the statistics to provide better information to police officers. Nanotechnology will help create an ultra-dense mind that will definitely enable our society to store this wide range of information. However, it also provides the motivation for ultra-efficient formulas for handling, encrypting, and also corresponding information without compromising its own integrity. There are numerous examples of big data processes being successfully carried out in real time by very small systems, including the components of the eye and ear that convert external indicators into information for the mind. Researchers currently dispute the potential impact of nanotechnology. Nanotechnology might be able to create many brand new components and also tools with a considerable number of uses, including in nanomedicine, nanoelectronics, generating electricity from biomaterials, and also for individual items. On the contrary, nanotechnology raises a number of concerns similar to those of any other brand new modern technology. These include questions about its toxicity and ecological impact of nanomaterials and their potential impact on the international economy, as well as opinions on a range of doomsday circumstances. These questions have sparked a dispute between interest groups and also federal agencies over whether nanotechnology really needs unique moderation. And that's it for today's video, and thank you for watching. I hope you enjoyed it. If you enjoyed the video, please give it a thumbs up and share it with your friends. Don't forget to share your thoughts and valuable feedback with us in the comments below. You can also suggest what topics we should cover in our next videos. And finally, if you haven't subscribed to the channel yet, subscribe. And if you want to see more videos like this, hit the bell button to be notified every time I upload an interesting video to the channel. So, I'll see you again in the next video. Bye!